All right, we are going to do 4.4 other common functions. For this one, we're going to take a look at a series of very common functions that we have. A lot of it I'm going to draw off to the side because for this lesson, it's really about just looking and understanding what's happening in the graphs and determining from there what kind of function you're looking at. So again, we're going to start at the practice. There's not a whole lot to these. A lot of it just comes down to looking at what you have and then looking at the options that we see down here. Before we even get into it, though, a lot of this is all about graphs. So we're going to draw a series of graphs. They do not have to be perfect. Mine will not be. And then we'll go from here. So let's take a look at x. A graph of x to the first, or just x, will look something like this. With arrows. If I take x to the second, I get something. This is going to be false, but it portrays what I need to the most, and that's that it looks something very similar to that. If we go one more, we have x to the third power, and it'll look something similar to this. If we have x to the fourth, it'll look like that. And from here on, most of everything that we do is going to follow this pattern. And the pattern is simply how many times should I theoretically cross the x-axis? Remember that all of these are just x-axis. So if I look here, how many times did this red line cross the black line? Well, once. How many times did it cross? Twice, so x to the second. If I look here, it would cross 1, 2, 3 times, so x to the third. X to the fourth, 1, 2, 3, 4. X to the fifth, 1, 2, 3, 4, 5. And so with these basic functions, we can take a look and very quickly decide what type of graph we're going to look at. Also, we're going to take these graphs and we're going to just change them slightly on the next 4 because we're not going to do x to the fourth, x to the fifth. Most of these, again, you should fairly, I'm going to say confidently, be able to do without too much struggle. So what if we say negative x to the second? Well, that is going to look like this. If I say negative x, because I did this out of order, it would look like this. Negative x to the third will look something similar to this. Negative x to the fourth will look like that. So why? What's the difference between these graphs? Well, on this one, my right side, is my right side going up or down? On this one, my right side is going up because this is positive. This one, what's happening? My right side is going up because this side, it's a positive x squared. For this one, my right side is going up because this is a positive x to the third. For this one, my right side is going up because it is a positive x to the fourth. For the last one, this is a positive x to the fifth, so my right side will go up. Taking a look at the other ones, it's all about your right side. Since this is a negative x, or negative x to the first, my right side is going down. Negative x to the third, my right side is going down. Negative x to the second, my right side is going down. Negative x to the fourth, my right side is going down. And so these are the basic graphs that we're going to have to work with. There's also more, and so let's get to the hand tool and let's create a few more. But all of these still follow that same general rule that if it's positive, my right side's going to go up. If it's negative, my right side's going to go down. So if I have a function that I'm talking about, the square root of x, or the cubed root of x, or the fourth root of x, maybe we're going to talk about the seventh root of x. Well, these all share very similar looking graphs. Square root of x just kind of pops off to the side. A cubed root of x, curves to the left, but it also curves to the right. This one, a fourth root of x, just has a top. A fifth root, a seventh root, a ninth root of x all behave the same way. I have this spot that goes off to the right, and I also have this little arc that goes back to the left. On even roots, so for like the square root, I just have this single curve off to the right. But again, all of these, my right side is going up. Why is my right side going up? Well, because all of these are positive. If I had a negative square root of x, my graph would be down to the right. Looking over here, we also have two more types of graphs. This one is a graph of x to the second on the bottom, and then this one is a negative absolute value. So if we look here, all we're really caring about is the negative sign, which tells me that my right side is going to go down, which right side goes down, right side goes down, right side goes down, and my right side is down. And then all we're going to look for is this part right here, which is x to the third. Well, this one is just a root. This is an absolute value because these lines are perfectly straight. While it doesn't loop exactly, this right here is going to be our negative x to the third. Then what it wants you to do is just find some coordinates on this graph that sit between negative 10 and positive 10. You are just going to, unfortunately, have to do some math. It doesn't really matter what numbers you pick. If we say s of x equals negative 7 over 5, x to the third, I can't use 0 as much as I would love to, and generally what I would say is always use 0. It's a great number to pick. For us, though, it wants two numbers, so let's just give it two very easy numbers to work with. One of those numbers I'm going to say is, let's find s of 1, and then let's find s of negative 1. So, negative 7 over 5 times 1 to the third. Over here, negative 7 over 5 times negative 1 to the third. And now you're just simplifying. 1 to the third is just 1, so I have negative 7 over 5 times a 1, which just means that I have negative 7 over 5. Coordinate for us then is 1, negative 7 over 5. On this right side, negative 1 times negative 1 times a negative 1 keeps that negative 1 times a negative 7 over 5, which now equals a positive 7 over 5. So the next coordinate we have is negative 1 and 7 over 5. So now we just got to type them in. So our first one is 1, and then negative 7 over 5. Oops. 7 over 5. And then this one is a negative 1 and a positive 7 over 5. that's one of them done. This one, again, we're just looking first right here at this negative sign that's just saying that my right side is going to be going down. And so this one, my right side is going down. This one, my right side is going down. This one, my right side is going up, so I can automatically eliminate this one. This one also has my right side going up, so again, I do not need to worry about this one. Then I'm going to look at the function itself, which is just the absolute value of x. Absolute value of x is this V shape, and again, because it's negative, it's going to go down. And then we just need to find some coordinates. Again, you're going to write the equation down. You're going to pick a set of coordinates that you want to work with, and then you work with it. So we have h of k equaling a negative 8 over 3 times the absolute value of x. To make this easy on ourselves, again, I think we're going to do h of 3. And we're going to do h of negative 3. So negative 8 over 3 times the absolute value of 3. And we have negative 8 over 3 times the absolute value of negative 3. This again is just negative 8 over 3. The absolute value of 3 is 3. And over here, if we have negative 8 over 3, the absolute value of negative 3 is a positive 3. So the great thing about absolute value functions, you really, if you pick the same number, you only have to do the equation once. Negative 8 divided by 3 times 3 is just negative 8. So we have the coordinates 3, negative 8. And we also have the coordinate negative 3. Negative 8. And now we type. So 3, negative 8, negative 3, negative 8. There it is. We'll go to the certify real quick. Again, this is going to be random, so this is a negative x to the second. This is a positive odd exponent greater than 1, so this could be x to the third, x to the fifth, x to the seventh, but a positive x to the seventh. This one is a positive absolute value of x, and this one is going to be our negative x. Because this is x to the first, it theoretically would only cross one time, and my right side must be going down. So we'll submit that. And again, we're going to pick numbers that we want. Again, you cannot use the origin, but you can use whatever else. So back on our sheet, let's take a look now what that would look like. We have p of x is equal to negative 3 over 4x. So let's try to find some easy ones to do. Maybe we can do 4. And then what would happen if we did negative 4? So p of 4 would be negative 3 over 4 times 4. And then p of negative 4 would be negative 3 over 4 times negative 4. These two basically will cancel each other out, leaving us with 4 and negative 3. And then over here, 2 negatives make a positive. These two cancel each other out, so we get a negative 4 over a positive 3. Always fun. So again, now we're going to try it. Hopefully we got this right. And there we go. Again, for this one, we're taking a look at a negative 4 over 9 times the absolute value of x. This is a negative number, so my right side will be going down, and it is an absolute function, so it'll be this one. There we go. Hopefully that helps.